Hi, I'm Sandon Jacobs from Confluent. When it comes to building event-driven applications, two things can be true at the same time. Apache Kafka is the de facto streaming platform for event-driven architectures, and point-to-point traditional queue-like messaging systems are an established pattern for building event-driven architectures. Recent enhancements bring this queue-like functionality into Apache Kafka. So let's unpack KIP-932 queues for Kafka. So let's start with stream processing, and that's where the little Kafka Consumers 101. We're going to draw our Kafka topic here with three partitions, because we're obliged to do that every time we talk about parallel processing in Apache Kafka. And messages are produced to these partitions from our Kafka producers. And on this side, we have our consuming applications that are processing these events. And because they all have the same consumer group ID, they belong to what's known as a consumer group. Each one of these consumers, when it communicates with the broker, receives a partition assignment, and is assigned a partition of our Kafka topic. And that is a one-to-one ratio. If we decide to start yet another instance of a consumer in that same consumer group, well, this guy, he's just going to be idle and not have a whole lot to do. So what we have here is parallel processing. We have ordering guarantees, and that these consumers are processing the events in the order they were produced. But we also have this one-to-one ratio of consumers to partitions, and we can't scale beyond the number of partitions. Now let's talk about the point-to-point world of traditional messaging, where instead of having a partitioned log, we have a single work queue here with all of our events in this work queue. And we have subscribers that will be processing the events from our queue. And each consumer or subscriber reads a different message from the queue. And when they do, they actually delete it as they read the event. This prevents other consumers from consuming the same exact event as one of their counterparts. So these events are processed by only one consumer. They're deleted on read. And these events typically represent an individual piece of work or some task or unit of work. But most importantly, what we have here in this scenario is message level acknowledgement. And we also have very different scaling properties here. So this scaling is very different than scaling on the Kafka side, where we can't add any more consumers to that partition, but we can continue to add subscribers to our work queue. So now the question is, how do we get some of this point-to-point functionality into Apache Kafka? That's traditionally been a square peg in a round hole when it comes to Kafka, but that's where KIP-932 enters the picture and introduces us to this concept of cooperative consumption. How, you ask? Well, for starters, the API exposes a new construct for consuming called a share consumer. This share consumer, or instances of this share consumer, are capable of consuming events from the same exact partition. How? Well, that brings in another new construct on the broker side called a share partition, so that the share consumers are actually going to consume from the share partition. So the share partition isn't an exact copy of everything that's in the underlying topic partition. No, it's rather, it is a pointer back to the data in the underlying topic partition. For instance, in this scenario, we have references back to partition number 3, and members of our share consumer group are now able to consume from the same exact partition. How does the share partition track this cooperative consumption model? To explain that, we're going to zoom in more on this concept of a share partition. Bear with me, this might get busy, but I promise you it'll all make sense in a few minutes. This is the share partition, and events in the share partition have 3 attributes. They have the offset. We all know and love that from our time with Apache Kafka. Each event in the share partition also has a state. State will make sense in a minute, I promise. And a delivery count is the other attribute that the share partition is keeping track of for us in our shared consumer model. We're going to go ahead and assign the offsets. We know what those are. Kafka folks in the house rejoice. I don't want to gloss over the fact that the offsets here in the share partition correspond directly to the offsets from the underlying topic partition. That's important because that's how we're going to keep track of how we've consumed what we've consumed. Okay, stay with me. So let's talk more about this property of state in our share partition. There are 4 states of messages in the share partition. The first is available. As the name implies, when an event makes itself known to your Kafka topic, it is in available state. The next state is acquired. And we also have acknowledged, and we also have archived. Now let's talk a little bit about transitions to these different states. By default, you can allow the new Share Consumer API to just handle these transitions for you implicitly. That's the default behavior. But if you'd like more fine-grained, granular control over how your events are processed specifically in error conditions, then you'll want to use explicit mode, and you'll have direct access to these acknowledgement types that drive these states from within your code. Let's talk about these transitions a bit. So let's start with how messages are acquired. A consumer, or share consumer in this case, polls and fetches a set of events from the share partition. Any events that are part of that fetch are transitioned from the available state to the acquired state. And on each event, remember that delivery count property that we talked about earlier? That delivery count for each event is incremented. The other thing that happens in this transition from available to acquired is this event essentially becomes locked. And along with that lock, there's also a clock in the background. This is the amount of time that this consumer has to do something with this event and let the share partition know that it actually processed it either successfully or unsuccessfully. So let's talk a little bit about the go right path here, how we go from acquired to these other states. We processed this event, everything was great, we processed it successfully. Now we can use the acknowledgement type and the acknowledge method on our consumer with this specific message to say everything was fine. We're going to accept that this message was processed, and now this message transitions from the acquired state to the acknowledged state. And that is a terminal state. This event has now been processed by this share consumer group. Now we've talked about the go right path. Let's go to the error conditions. Not all errors are created equally. Some messages are just garbage. And in that scenario, we are just going to use that acknowledge method that I talked about on the share consumer to reject this event. Perhaps somebody needs to take a look at it, but we need to move on with our life and process the rest of our messages in our consumer group. Now that we've talked a little bit about the state machine, it's worth noting how this affects the state of our share partition. So let's fill in some of our state for messages. And again, this is a point in time, just a time slice of what states in your share partition may look like. And we're going to explain how this manifests itself in just a moment. We've got some messages that are acknowledged, some that are in acquired state, some that are available, and some that have been archived. So how does this state relate to delivery count? Well, by definition, anything that has transitioned from available to acquired has a delivery count of at least one. So that also covers anything that is acknowledged, anything that is acquired. Now, these newly available events here, when they're newly available, they have a delivery count of 0 because they just arrived, they just got to the party. Also, our archived message here, it's been delivered at least once and is now in this terminal state, won't be processed again. So again, we have these newly available events, just got to the party, they have a delivery count of 0. But we have these other available events in our share partition that they may have been through a couple of state transitions here. How? Well, remember our lock and clock on our acquired events. Well, what happens when that lock expires? Or you, as a developer, you encounter an error in your processing, say with some synchronous process that is not returning as friendly as it should. You can explicitly release the event. Remember our acknowledgement types on our acknowledge method in our consumer? We can choose to release that event, and then we have decisions to make. So these two scenarios depend on that delivery count property of the message. Is the delivery count less than our max? And the default for that max is 5. This is the maximum number of times that an event can transition from available to acquired. Now, if the delivery count of the event is less than that max, it can go back to the available state. And future polls or fetches of the consumer can grab that event again, back into the acquired state it goes, and we attempt processing. The other scenario with the delivery count is if I've been through this transition the maximum number of times, meaning my delivery count equals 5. Well, I've already tried this thing several times. We're going to give up and archive this event. So that means that our available events could have a delivery count of 2, could have a delivery count of 4. And that fills out this point in time for our state in our share partition. So given all this, let's talk about how our share partitions know which events they can and can't process from our share partition. Well, the first available or acquired event in our share partition is known as the share partition start offset. This is the beginning of a window that your share consumer can fetch from in the share partition. There is a configurable number of events that can be in what we call the in-flight records window. And that in-flight records window is this offset plus that number of events, and the end of that in-flight window is known as the share partition end offset. So when a consumer polls, it's going to grab events that are available from this window of time, the in-flight window. So as this event at the share partition start offset transitions from acquired to one of our terminal states like acknowledged or archived, this window of in-flight messages is going to move as this start offset moves. So here's some other important points about queues for Kafka. Unlike a lot of point-to-point systems, there's no max queue depth here. If you've got disk, you can keep storing this data. Also, you have this ability to reset to a point in time to consume this data in this queue-like fashion. So don't think of this as a queue per se, think of it more as a cooperative consumption model. This data in our Kafka topics and the underlying Kafka topics, nothing changed there. If you have a stream processing use case for that, feel free to keep going the way you've done before. Think of this more as a durable subscription model. That's what I like to think of when I hear the term share group. So what does this mean to you? Well, as of time of this recording, this is available in Apache Kafka 4.1 in preview release. What does that mean, Sandon? Well, this isn't production ready yet, but feel free to go out, experiment with it, see how this applies to your queuing use cases. This should be generally available in some upcoming releases of Apache Kafka. What can you look for in the future of KIP-932? Well, for starters, consumer metrics. We need observability here to peer behind the curtain of where we are with our consumers in relation to this share partition. Another thought is DL queues or dead letter queues in our error scenarios. We'd also like to add something like exponential backoff in this retry scenario so that we're not instantly retrying messages or almost instantly retrying messages. And another thing that you may have noticed is we've lost our concept of key-based ordering that we have with our traditional consumer groups. Can we bring that into queues for Kafka? Stay tuned for that. And there you have it, KIP-932 queues for Kafka. Thanks for watching. Leave us a comment, leave us a question. Go check us out on Confluent Developer. Bye for now.